Last week, I showed you 10 different ways to draw a circle using JavaScript. And in one of those, we rotated the canvas and always did the line to the same location. That was done purely in code, but it got me thinking, can we make an app like that? A spinning HTML canvas that lets us draw on it, kind of like how pottery is made. And spoiler alert, we can, but we need to use a bit of math, the vector math I taught in that other video. But this time, we'll put a new spin on it. Get it? Spin, because the canvas is... No, no, no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
I'm going to use Visual Studio Code, and in an empty folder, let's create our index.html file. And let's begin with basic HTML syntax. Opening and closing tag, and then in the head section, let's give a title to our page. It's going to be spinning canvas drawing app, like so. And we will be doing the drawing on a canvas element. So inside of the body section, let's create our canvas element like this. Now we can open this HTML page also in the browser. I'm using Google Chrome here, and you can see the title appearing here at the top. And I always recommend to keep the developer tools open. They will show that we do have this canvas element also on the page. It's just transparent, so you wouldn't know it's there otherwise. Let's give it some style, and let's implement our styles in a separate file because this is a little bit bigger project. So I'm just going to do that here, and we can create a new file in Visual Studio Code by control-clicking this. It generates it here. So the canvas is going to have a border. I'm going to give it a solid border. It defaults to black, and now when we refresh, we see it like this. Let's also move it in the center of the page. So for that, we go back in the CSS and say position absolute and left 50%, top 50%. Now, this is going to make the top left corner of the canvas in the center of the page. We also have to translate it by half its width and half its height towards the left and to the top. So back here, we are going to say transform, translate, -50%, -50%. And if we save and refresh, we get now this look. It's good, but I'm going to make it a little bit larger. This default size is 300 by 151, and let's make it 400 by 400. Now, a small thing is you could set the width and height values here in CSS, but that's not actually going to change the size of the canvas. It's only going to stretch it, and you will get some weird artifacts from that. So it's important to set the width and the height here when defining the canvas. So width 400, height 400. And saving this and refreshing, it's going to give you that. We have to refer to this canvas somehow when we write our code in JavaScript. So let's give this an ID of my canvas, like so. And the JavaScript code, I'm going to link it here in this script tag. Let's say main.js. Control-click on this to create the empty file. And we can now start to write our JavaScript. And we will do the event listeners. So typical event listeners for drawing app is the mouse down, but now we are going to use pointer events because I want to see if this will work nice on the mobile devices as well. So let's see. First, let's get the drawing context from the canvas to the context like this. And let's add the event listener for pointer down on the canvas. And what we'll do here is we will begin a path and move to the location that is existing inside of this event, of this E variable. So move to E offset X, E offset Y. We just move there, and we also mark that we have started a new drawing. This variable drawing set to true is going to be important when we do the pointer move event. When we move the pointer, we only have to process it if the drawing is on. So I'm going to go down here and add a pointer move event listener like this. And if we are drawing, then I'm going to do a line to the offset X, offset Y, and then stroke. So this is going to make a very small line from where we started to where we moved just now. And now I want to repeat this. I want to remember this location and then draw a new line in the future when it comes. So a way to do this is to begin a new path like this and move to that location. So same as this. So now we are ready for the next pointer move to happen. We also have to be able to stop this drawing somehow. So I'm going to go here and add a pointer up event where I'm just going to say drawing is false. So this is a basic implementation of a drawing app here. I have a more complex one in the machine learning course first lesson, but this will get the job done. I'm just curious what it takes to implement the drawing app on a rotating surface. So not gonna go too deep into these mechanics this time. Let's save this and refresh. And now if you click and move, it's gonna make a line appear there. And if you release the mouse, it stops making that line. And you can make many lines like this. It seems to work. One problem that often happens is when you leave the page and then come back in, this line continues. And this may not be a good behavior for you to have, especially if you come back in somewhere here, then it's going to draw that line connecting those locations, and it's something like a glitch, and people tend to not like it. It's better to go back here, copy this, and say here pointer leave. So this means now that when you are drawing something like this, pointer up still works as before, but if you're leaving and then entering again, it stopped the drawing because pointer leave triggered here. Also, one thing that I wanted to mention is you could implement this in a little bit more efficient way. I almost never get the chance to talk about this, so might as well do it now. Basically, this pointer move event should only be processing after you have started the drawing here. So homework for you, try adding this event listener here, but then remove it when pointer leave and pointer up. And to remove it, you're going to need to give an actual name to this anonymous function here, because that's how the remove event listener works. So it's going to be a little bit more efficient if you don't do anything, just move the mouse around. It's not going to process anything. but it can be a little bit tedious to remove this event listener sometimes, and if you miss some special case, you might end up with 2 event listeners for pointer move that are running, and it's kind of dangerous behavior. So I tend to use this extra variable here. Anyway, let's try to get this to rotate. So for that, we're going to animate, and we're going to have a variable here, rotation angle. And let's make our animation loop here at the bottom and say animate. This is going to be a function we implement. And in this function, I'm going to say rotation angle +1. Let's increase it by 1 for now. And let's say that this is in degrees. So it's a slowish increase on each frame. And then my canvas style transform. So the one that we have set here in CSS before, we still have to keep it so that it's offset to the left and towards the top. So I'm going to type here translate -50%, like that. But I'm also going to add here this rotation angle and mention that we want this to be in degrees. And now we have to call request animation frame and pass here the animate function, because this is going to now call animate again and again and again, always increasing the angle and setting the style to the my canvas canvas. And it's going to try to do it 60 times per second. So let's save this and refresh. And this is what we get. You can see here in the developer tools how the angle is changing, but then the translate always stays the same there. Funny how this, well, I can't point to it, but how that tooltip is bouncing there when I'm hovering here. Okay, but does the drawing work? And at first glance, if you always move your mouse, this seems to work. But if you stop moving the mouse, it doesn't draw the line there. And if you move it again, it's gonna do that kind of annoying move there. So if you're happy with this, great, we are done. Thanks for watching. But if not, we're gonna have to do some fixing and figuring stuff out. So the problem is this pointer move event is not going to trigger unless we move the pointer, right? And if the mouse is standing still, then it's not going to update. And fixing this problem is harder than it seems. So what I tried to do first is take out this event from here, this E value, store it in this event info global variable. I'm just going to define it here at the top. Let's have it null in the beginning. And then cut out all of this functionality. And instead of having it on pointer move, having it inside of the animate function here happening on every frame, right? But here we can only do this drawing if there is that event info, because it can be also null there. And we need to pass this event info, the global variable now, here, 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 and here. Let me also separate this block a little bit. Okay, so does this fix it? Let's see. Refresh the page, and you start to draw, and the same thing as before, pretty much. So what happens here is this block of code does execute. It does execute all the time. We don't need to move it. Look, if I'm going to put here a console log, just an exclamation mark, refresh. And now I'm going to draw something. Let's take out the console. You can see here the exclamation mark appearing there. Let me just clear this and do it again. So I'm drawing something, it's appearing there every time I'm drawing, and if I stop, it's still appearing there, even if I'm not moving the mouse. So that code is executing. The problem is these values, they don't change anymore. Like offset x is going to stay the same even if that code, you can see it there at the bottom counting the same value again and again. If I don't move the mouse, it's going to do this. So very annoying. We almost got the app working, and now it's making these complicated things happening. And really, the only way I could figure out how to solve this problem is to do mathematics, is to figure out what is the coordinate that needs to be plugged into the canvas there. And a simple way to do it is, in my opinion at least, to consider the 0, 0 coordinate in the center of the page, and then the mouse location relative to that 0, 0 coordinate first. And then after we get that mouse location relative to that, we will convert those coordinates, those x and y coordinates, into polar coordinates. So we just get the angle and the magnitude. So the direction and the magnitude from the mouse. It's essentially the same thing, but represented in a different way. And then to the direction, to the angle, we have to pass this rotation angle that we're working with, and then do a conversion back to the Cartesian space, to the XY space. If you don't know what I'm talking about right now, you may want to watch my video where I teach these things in more depth. But now we're going to use them to solve this problem. So let's begin. Here, the first step will be to get these x and y coordinate relative to the center page. The x is going to be the page x minus, and now I'm going to use the inner width of the window divided by 2. So this is going to be the center of the page where the canvas is spinning. And the same thing happens for y here, the page y minus window height divided by 2. And now from these, we need to convert to polar coordinates to get the direction and the magnitude, the length of the vector. So to polar, we're going to need to implement this, and we pass this xy value like that. And then let's subtract the rotation angle, and these need to be in radians. It's going to be easier to work with because typically sine, cosine functions and other things that work with angles in JavaScript, they work with radians. So we are going to multiply here by pi and divide by 180. This is a conversion to radians from degrees. And then we need to do the conversion back to a Cartesian space. So we get this 2xy function that we need to implement from the new polar coordinates with the different direction. And finally, we have to consider again moving back to the center of the canvas, because otherwise we are doing things relative to the 0, 0 coordinate of the canvas, and that's somewhere spinning around, and everything so far was relative to the center of the page and the center of the canvas. So this needs to be translated back there. In my tutorials about these things, you also learn about vectors. You also learn about other operations like subtraction, addition, and this code could be made much nicer. But now I just want to focus on this 2 polar and 2xy functions that still need to be implemented but are really useful. So let me also remove this console log from here. And now, very important here is to pass the new values to this line to, and also to the move to. So I'm going to say here xy with rotation x and xy with rotation y, like this. And to polar, to xy, I'm going to implement them at the bottom here. So to polar from xy, I'm just going to destructure them here, like so. And I return the direction, which is going to be coming from the arctangent2 method of the math library. And then the magnitude is the hypotenuse. It's basically like using the Pythagorean theorem here, but the other point is 0, 0. So we don't need to do any differences here. And then the 2xy function is going to use the trigonometric circle. So we return here the x is going to be the cosine of the direction times the magnitude, and y is going to be the sine of the direction times the magnitude. Like this. So a lot of work, and I sped through it because I do explain these much better in the other video, but really I can't think of another way to implement this. And if somebody else has a solution for this, then using math, then thanks, I hope I see it. But that's the easiest way I found to solve this problem. And even if it's a very small application that we are trying to build, because it's kind of a unique thing, like you don't see these kind of applications everywhere, there is not really support for making these easier, I think. At least it's my opinion. So let's save this and refresh. And now I'm going to click and look at that. It's going to draw the circle with the same strategy I was talking about in the video on how to draw 10 different circles. There I showed one way you can draw a circle is actually to spin the canvas and keep the point that is doing the drawing fixed. And now we can see it in practice. So what about that? But of course, you can draw more complicated things as well. Like I can go down like this, and now this becomes a kind of a spiral or something like that. I think it could be much better if you have a drawing tablet and more control over this than my bad mouse movement. I would also like to control the rotation speed. Like maybe I don't want everything to spin all the time. Maybe I want some parts of the drawing to be done without a spinning canvas. So let's do that real quick. I'm going to go in index.html, and below the canvas, I'm going to use an input to define a slider. So it's going to be a range type, and then let's say speed slider like this. And let's allow it to go in both directions, so negative speeds as well for that, -3 + 3. And the step we control the speed is 0.2. So every time we move a little bit, it's going to change by 0.2. These are in degrees. And the initial value is going to be 0. We don't want it spinning at the start. And when we change this value, let's call a function update rotation speed, like this. Let's save this file, and now let's go to main.js, at the place where we are changing the rotation angle. We're gonna need to use the rotation speed instead. So this is a global variable here, rotation speed. I'm going to set it to 0, and that function that changes it, let's leave these utility functions at the end right here and say update rotation speed. And I'm going to parse the value. I want the numerical value of this, because I'm adding it to this rotation angle, and if it stays as a string, it's going to concatenate it, and strange things are going to happen. So that's why I'm parsing it to be a number. Let's save and refresh. And now the slider is here, the canvas is not moving, but if I move it to the right, it speeds up, slows down, and going in the other direction as well. Let's make this a little bit better so that we know what this slider is. I'm going to go back to index.html and quickly add a label for this speed slider. Let's just say speed here, and a new line. I want it to be on top of the input. Save and refresh, and let's put it in the middle of the page. So in the style sheet, I'm going to define a style for the body, and it will have a text align to center. And let's set its font family to Arial as well. I like it a little more. So now when we refresh, it jumps here like that. And let's try to draw something. Let's make it spin really, really fast, and maybe I try that spiral again. Okay, and let's try to draw a snail. So I'm gonna align this canvas like that, and I think this needs to now go down like this.